The table shows information about the heights of 80 children. So we've got a frequency table here, and we can see that there are 4 children that are between 130 and 140 centimetres tall, 11 children that are between 140 and 150, and so on. We're being asked to find the class interval that contains the median. Now, class interval is just another way of saying category. So we're just asking which of these categories here is the one that has the middle number in it. Remember, the median is in the middle. Now you've got 80 children. To find the position of the middle, we add 1 and divide by 2. Always add 1 and divide by 2 if you want the position of the middle. So that's 81 divided by 2, which is 40.5. So that means the 40.5th piece of data is in the middle. That means the middle number is between the 40th child and the 41st child. So where are those children? Where are those middle 2 children? So the first 4 children, the shortest, are in this first category. We've not got to the 40th child yet. And then there's 11 more children, and that means that up to this point there have now been 15 children. So we still haven't got to the 40th child yet. And then there are another 24 children. So up to this point we've then had 39 children so far. So both the 40th child and the 41st child, and a few more children, 22 of them to be exact, are in that next category. So the category that has the median child in it, the middle child, is in the category 160 to 170. We've then got to draw a frequency polygon for the information in the table. So for a frequency polygon, you're going to plot each value just as it is. The frequency is going up the y-axis, you can see that there. So we've got 130 to 140, we're going to plot 4. Now for a frequency polygon, you plot that in the middle of the category. So we're going to go across to 135 and go up to 4. We've then got 140 to 150, we're plotting 11. So that's again going to go in the middle of that category. I've then got 150 to 160, I'm plotting 24, which is here. And again, I'm plotting that in the middle of the category. 160 to 170, so I'm going to plot at 165 and go up to 22. And then I've got 170 to 180, and I'm going to go up to 19. Now, all we do then is get our ruler and we join them up with straight lines. So from 135, that coordinate there, to that one there. And I normally like to tell my class it looks a little bit like a shark fin, although this one maybe not so much, but there we go. Plotting in the middle of the categories and joining them up. Don't join the last point to the first point and don't need to connect it to the origin. That is how it looks. Okay, question number 3. A gold bar has a mass of 12.5. The density of gold is 19.3 grams per centimetre cubed. Work out the volume. So for this, we're going to need our formula triangle: density, mass, volume. We want to know the volume, so if we cover that up, we're doing mass divided by density. That's the sum that's left when we've got one on the top, one on the bottom. So mass divided by density is 12.5 kilograms divided by 19.3, and this is a calculator paper. And this is a calculator paper, so we can just type that on our calculator. 12.5 divided by 19.3 is 0.64766, and it wants it to 3 significant figures. So remember, 0 does not count as a first significant figure, but once you've started counting, it would count. So 6 is my first significant figure, then 4, then 7. So I'm stopping there, check the next number which rounds up, so it'd be 0.648. Question number 5, find the value of the reciprocal of 1.6. Now, a reciprocal is when you take a fraction and you turn it upside down or invert it so that the bottom number becomes the top and the top number becomes the bottom. So the reciprocal of 2 over 3, for example, would be 3 over 2. The reciprocal of 4 over 5, for example, would become 5 over 4. Now, 1.6 is not a fraction, so it's quite hard for me to do. But I could say that 1.6 is the same as 16 divided by 10. That's the same thing, right? And then we can do the reciprocal, but before we do the reciprocal, I'm going to simplify it. So I'm going to change it to 8 over 5. So then the reciprocal would be inverting that, and that would be 5 over 8. So then 5 divided by 8 as a decimal is going to be 0.625. Great, Jess rounds a number x to one decimal place. The result is 9.8. write down the error interval for x. So when you've rounded to the nearest one decimal place, you've rounded to the nearest 0.1. You're going to divide that by 2, and that means we're going to put 0.05 above and 0.05 and 0.05 below. The result is 9.8. Write down the error interval for x. So we know x is going to be in the middle. We know the smallest that x can be is 9.75 because we've gone 0.05 below, and the biggest that it can be is 9.85 because we've gone 0.05 above. It can actually equal that bottom value, but it can be anything up to that top value. That's our upper limit, the top one there. Okay, great. Question 7, work out 13.8 times 10 to the power of 7 times 5.4 times 10 to the power of minus 12. So you can just type this in your calculator all as one. You could work out each bit individually if you wanted, but I'm just going to put it in just as it is. So open the brackets, 13.8 times 10 to the power of 7, and I'm going to make sure I come right out of the power, shut the bracket, times 5.4, and again I've opened new brackets for this one, 5.4 times 10 to the power of minus 12. So I'm putting it in my calculator exactly the same as you're seeing it on your screen in front of you, and then I'm pressing equals, and actually my calculator is giving that to me in standard form, and it's saying that it's 7.452 times 10 to the power of minus 4, but we've been asked for it as an ordinary number. So I now need to write that as an actual ordinary number. We know that times 10 to the power of minus 4 is the same as dividing by 10, dividing by 10, dividing by 10, dividing by 10, 4 times. So it's going to be 0.000745. And that was the whole number, so we're going to write it all on the answer line. With negative powers, the number of zeros is always the same as the power, but with positive powers it isn't. Okay, question number 9. Jack bought a new boat for £12,500. The value, V, of Jack's boat at the end of n years is given by this formula. At the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? So for this, I would just use trial and error. We know that that power, that is represented by the number of years. So we've got 12,500 times 0.85, and then I'm just going to do it to 1. I'm going to do it to 2, I'm going to do it to 3, and I'm going to see how many years would it take. So I'm typing it in my calculator just as it is there, 0.85 to the power of 1, and that is 10,625. I'm looking for it to be less than half, so I need it to go below 6,250. That would be less than 50%, so that was no good. Now instead of clearing it, just use your left and right arrow, go back to the indices and change it to 2. And that is, so 0.85 to the power of 2, and I'm still using that 12,500 because I'm trying this instead, and that is £9,031.25, so that's no good. I'm going to jump a few here just to see if we can get straight to the answer a bit closer. Okay, so I've gone 12,500 times 0.85 to the power of 5, and that is 5,546, so that is below, but let's just check that 6 wasn't below as well. 4 wasn't below, sorry. So let's change it to a 4 and see if that was above or below. That was 6,525, so that was still above. Okay, great. So this was the first time that it went below, so 5 years. Now there is a slightly quicker way, and that is by looking at just the multiplier. This would be the first multiplier that was less than 0.5. So if you do 0.85 to the power of 5, it is 0.44. So that bit was why it went under half, whereas 0.85 to the power of 4, that was 0.52, so that would have kept it still above half. So you can just look at the multiplier bit if you want to know what the effect is going to be. Okay, a savings account pays interest at a rate of R% per year. Jack invests 5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20. Work out the value of R. So this is 60%. Okay, so £79.20 is equal to 60% of his interest that he got. So we know that because we know that 40% of the value has already come off in interest. So to get what that is as 100%, to find out how much how much interest he made altogether, there are a few ways you can do it. You can divide by 60 times by 100. You could divide by 6 and times by 10, or you could divide by 0.6. Any of those answers would get you the correct, any of those methods would get you the correct thing. I'm just going to divide by 0.6 because it's probably easiest, and that's £132. So we know that the interest he got on the account was £132. So then 132 out of 5,500, what percent interest was that? What percentage interest did he get? 132 out of 5,500 is 0.024, and if we times it by 100, because that's just a decimal at the minute, we can see that that is 2.4% interest. Okay, question number 11, we've got cumulative frequency graph, a topic that we're going to see most years, I think, on the exam papers. So the cumulative frequency graph shows information about the weights of 60 potatoes. Use the graph to find an estimate for the median weight. So if we want the median and there are 60 potatoes, a cumulative frequency graph works such that the weight of the 60th tomato, did I say tomato? Potato. 60 potatoes. The weight of the 60th potato would be 80 grams. The weight of the 50th potato would be 66 grams, and so on. So the potatoes are all in order, going from the smallest potato to the biggest potato. We want to know the weight of the median potato, which is going to be the middle potato, which is going to be between the 30th and the 31st, but I'm going to read across at 30 because it's a graph, so we don't mind if it's if we just read halfway, that's fine. And that would be 57. So I would say the median weight is 57 grams. Jamil says 80 take away 40 is 40, so the range of the weights is 40. Is Jamil correct? You must give a reason for your answer. So no, he isn't correct. We don't know that the biggest tomato was at 80, and we don't know that the smallest tomato was at 40. With a cumulative frequency graph, you plot at the top of the category, so it's likely that we're plotting this for all of the tomatoes that are between 30 and 40, and we don't know really between 70 and 80 where it's fallen as well for the categories, or if that even was the category. So because we don't have the original data, we don't know. So the data will have been in categories, and we don't have the original data. To be sure. Okay, great. Part C, show that less than 25% of the potatoes have a weight greater than 65. So let's see how many have a weight greater than 65. And to do that, I'm going to go up at 65, which is going to be here, and go across, and that pulls me across to 49. So that does not mean that 49 potatoes were more. We can see that the ones that weigh more are going to be these ones above. So 11 potatoes out of, there were 60 altogether. And we know that that's going to be less than 25%, but let's just make sure we write it as a percentage just to check. So 11 over 60 times by 100 to get it as a percentage, and that is 18.3 recurring percent, which is less than 25%. Great, question number 13. Write x squared add 6x minus 7 in the form x add a all squared add b. So this is completing the square. And we're going to half that middle number. So the 6 becomes 3. Let's go back to my original coloured pen. There we are. So we're going to do x add 3. Now the reason we're using 3 is because when I square this, I get x add 3 times another x add 3. And that gives me x squared. You get the add 3x from that bit and the add 3x from that bit, and then add 9, but that is always going to get you 6x. So by halving it and squaring it, you're always going to get the number of x's that you need. What we then need to do is get rid of this 9, because I didn't want the extra 9, so I'm always going to take away whatever this number is squared, and then bring down whatever is there. So it is x add 3 all squared minus 16. 2 marks, quite a nice question, that one. And then part 15, show the equation x cubed add 7x minus 5 equals 0 has a solution between 0 and 1. So if it has a solution between 0 and 1, we know on a graph a solution is when it goes through the x-axis. So we're looking for it to equal 0. But I know that if there is a solution between 0 and 1, then at 0 the answer needs to be too low, and at 1 the answer needs to be too big. So let's just check. 0 cubed, add 7 lots of 0, take away 5 is minus 5, which is too low. And then 1 cubed, add 7 lots of 1, take away 5 is 1, add 7, take away 5, which is 3, which is too high. So then we would just say must be a solution between. If it's negative when x is 0 and then it's positive when x is 1, it must have gone across the x-axis in between. Okay, show that the equation x cubed add 7x minus 5 equals 0 can be arranged to give this. Now notice that we've got a fraction here with two terms on the bottom. So it would seem that they have divided by a bracket, by something that's been factorised. So these can be quite tricky because it's not always obvious what to do, but I'm going to follow that lead. There's just a 5 that's been divided by a bracket. So let's start by writing x cubed add 7x equals 5. And we've got that by adding 5 to both sides. And now I want to divide by a bracket and I want to be left with x on this side. So actually if we factorise this left-hand side, then I've got a bracket, x squared add 7, which I can divide by. So x equals 5 over x squared add 7. That's that one. And then starting with x naught equals 1, use the iteration formula xn add 1 equals 5 over x squared add 7 3 times to find an estimate for the solution. So what we're going to do is put 1 into this. So we're saying to get to the next x, xn plus 1, we need to take 5, divide it by the current x, the one we're on at the minute, squared, add 7. So to get to x number 1, we're going to take 5 and divide it by x naught squared, add 7. And we're being told that x naught is 1. We're using that. So 1 squared add 7. So x number 1, the first x, or the second x, because we had x naught, is going to be 5 over 8, which we know is 0.625. And then that is our x1. So we're going to go again. And we're going to get x number 2 by doing 5 divided by 0.625 squared, add 7. So to get to the next answer, you're just putting the one before in. Just going to use my calculator. 5 on the top and 0.625 squared, add 7 on the denominator. And that gives us 0.6765327, blah, blah, blah. I'm actually going to keep that in my calculator. And for the last one, x3, because I said do it 3 times, I'm going to do that answer squared add 7. So I'm just putting that back in there. So I'm actually going to use my left arrow on my calculator to go back to that point. And then just delete that bit and put answer where it was. So answer squared add 7. And that is 0.67044. Did they give us how many decimal places to put it to? No, they didn't. So let's just go with that. So I would probably just write all the answers on my I'd write it all here. 0.67044 83001, and I'd probably just put 0.670448 on the answer line because they can see both answers, so that's absolutely fine. You definitely want at least 4 or 5 decimal places for that one. By substituting your answer to part C into that cubic, comment on the accuracy of your estimate. So if I put that back in to that, and I'm going to do answer cubed, add 7 lots of the answer, minus 5. So I'm using all the decimal places that I can by putting it in exactly. And that is 0.00544947, which is exceptionally close isn't it, to being 0. We're very, very close to 0. So it's a good solution close to 0. That's very, very close to being 0. So we found a pretty good answer to that cubic. Okay, question 17. ABC and ADC are triangles. The area of ADC is 56. That's the bottom one. Work out the length of AB. So I've got enough information in this bottom triangle to do some things. I don't have enough information in the top triangle at the minute to do anything, because in the top triangle I've got 2 angles and nothing else, which is not enough information. So first thing I'm going to do is look at this bottom triangle. Now in this bottom triangle we are told that the area is 56, and we know that the area of a triangle without a right angle with the perpendicular base and height or any of those things is half AB sine C. So we know that half times 11 times B, and this is going to be your B, because always with half AB sine C it's the 2 sides and the angle in between. So half times 11 times B times sine 105 equals 56. Now what we can do to get B is I can do half times 11 times sine 105 and then do 56 divided by whatever that is. So 0.5 or half times 11 times sine 105 is 5.3125 times by B equals 56. So to find out what B is, I'm going to do 56 divided by that answer, and that is 10.54. So this side here is 10.54099,384. Okay, cool. So now I need to get this side because that's going to be helpful, and to do that I need to use the cosine rule. So the cosine rule again takes the 2 sides, the angle in between, and gives you the opposite side. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So I'm moving the letters now because I need b and c to be the 2 sides that I know. So it's going to be a squared equals 11 squared add 10.54 squared minus 2 times 10.54 times 11. Should have done that the other way around, sorry. Cos 105. And then square root that answer. So I'm going to do 11 squared add answer squared. Again, because I'm using my calculator, I might as well keep it from as accurate as I can. Times 11 cos 105. That's a squared. So then I need to square root my answer. And that gives me 17.0. Oh, let me move that way. 17.09190364. Wonderful. And now we've got a pair. We can use sine rule in this top triangle. We are looking at that pair, and we want the length of AB over here, so we can use this pair to then get this pair. We want a side, so let's put the sides on the top. A over sine A equals B over sine B. So that means that 17.091 over sine 118, because they go together, equals x over sine 48. And then I know to get x, I need to multiply both sides by sine 48 to get rid of that fraction. There we go. So in my calculator, I'm going to put answer over sine 118, again I'm keeping the accuracy of that number, times by sine 48, and I've come out of the fraction to type that bit, or you can put it on the top, it's entirely up to you. And that is 14.38563268. They want it to 1 decimal place, so my final answer would be 14.4. Wonderful, very nice question. Prove algebraically that the straight line with equation x minus 2y equals 10 is a tangent to the circle with equation x squared add y squared equals 20. Okay, so if we've got a circle and if we've got a tangent, we're saying that there is only one solution. There's only one point of intersection. So when we do simultaneous equations with these two equations, we should only get one answer. If we got two answers, then we'd know that that line is going through the circle and it's crossing in two places and it wouldn't be a tangent. Okay, so let's do our simultaneous equations like normal, and there should be only one solution. I'm going to start by making x the subject of the formula here. So x equals 2y add 10. I've added 2y to both sides, and that means that we can now square it to get x squared. So x squared, and remember when you're squaring this side, you're squaring the whole thing, which means you're multiplying it by itself. So 2y add 10 add 2y add 10, which means that x squared is 4y squared add 20y, add another 20y, add 100. So x squared is 4y squared add 40y add 100. And I can now take that, because I know that it is x squared, it's the same as x squared, and put it in here. So I'm going to put 4y squared add 40y add 100, add another y squared equals 20, which is 5y squared add 40y. And then I'm going to take 20 away from both sides because I want it to equal 0 because it's a quadratic. So add 80 equals 0. Now everything is in the 5 times table, and because the right hand side of the equation is 0, it doesn't make any difference that I'm going to go and divide this by 5. It just makes it easier to factorise it if it does factorise. So y squared add 8y add 16 equals 0. And to factorise that, we would do y add 4, y add 4. So lo and behold, we can see that y equals minus 4 is the only solution. Let's just go ahead and complete this by putting it back in. So I'm just going to use this. X equals 2 lots of y add 10. So I'm going to do 2 lots of minus 4 add 10, which is minus 8 add 10, which is 2. So x equals 2. Therefore, 2 minus 4 is the only point of intersection. Intersection. Therefore, it is a tangent. Brilliant. Okay. And then last question, question number 21. OAN, OMB and APB are straight lines. AN is double 2 lots of OA. M is the midpoint of OB. O to A is the vector A. So we're going to write that in there. O to B is the vector B. Now I don't like when it's split in the middle, so I'm going to put half B on this side and half B on this side. And then it says, we know that this is also 2A because it says that A to N is double O to A. It then says A to P is K lots of A to B, where K is a scalar quantity. So it's saying this bit is a fraction of this whole line, but it's K, we don't know what fraction it is. Okay, so that's what we need to work out. It says that MPN is a straight line, find the value of K. So we know that if it is a straight line, like this, then I know that whatever M to P is, and whatever M to N is, M to N will be a bigger version of M to P, and it should be a multiple, and then it will be parallel, and that makes it a straight line. So we know that M to N will be a bigger version, okay? So what I'm going to do is I'm going to get M to P, and I'm going to get M to N. Now we know that this one will be a bigger version of this one, or a multiple of this one, and so we'll then be able to compare and work out what K should be. So M to P, we're either going to need to do this and this, or we're going to need to do this, this and this. But because I'm interested in K here, I'm going to go that way to make sure that I'm using it. So M to P is going round like that. M to P, I'm going to do it up here, is minus a half B, because I'm going back against this bit, and I'm going against the arrow, which is why it's minus. And then I'm going up this bit, so that's plus A. And then I'm going down this bit. Now, at the minute, all I know is this is a K of AB, but I don't yet have AB. So I'm going to put K of whatever AB is. Let's work out A to B. So A to B is going, I've written over this too many times now, that way. So I'm going to go minus A plus B. Oh, minus A plus B. There we go. So that is A to B. Now I know that that is what goes in here, minus A plus B. So M to P, just bringing this over to here, let's just sort that out. It is minus a half B, add A, minus KA, add KB. And so looking at just the A part, it is 1 take away K, lots of A, because I factorised this bit. And looking at the B parts, I've got K lots of B and I've got minus a half lots of B. So altogether I've got K minus a half lots of B. So that's MP. That's as far as we can go at the minute because we don't know what K is. Now I'm going to look at M to N. And M to N would be going back against this bit and then all the way up to the top. And that's going to be minus a half B, add 3A. Now, because we know that this makes a straight line, I know that MN is a bigger version of MP. So whatever it's been multiplied by, to get from MP to MN, this term here to this term here will be the same scale factor as this term here to this term here. So I therefore can write 3 divided by 1 minus K is equal to minus a half divided by K minus a half. So I've done green divided by green. The scale factor of that must be equal to the scale factor of blue. And then it's just our job to sort this out. So because I'm solving an equation with an equals in the middle, I can times this up here and times this up here. So 3 lots of K minus a half is equal to minus a half lots of 1 minus K. And that's 3K minus 1.5, or 3 over 2, equals minus a half, add a half K. Adding a half to both sides? No. Adding 1.5 to both sides gets me 3K equals 1, add a half K. And then if I take a half K away from both sides, I get 2.5K equals 1. I don't really like the fraction, so I'm going to change it to 5K equals 2, and so K equals 2 over 5. I've just doubled both sides just to make it a bit nicer. There we go, and that's your final answer for that one. Very, very tricky last question, but hopefully that makes sense.